Good, good pick. Any questions? How will this function look like? Well, it will have a vertical asymptote at 3, but it will have a hole at -1. So right here, -1, comma, -1/4 will be a hole here. Same idea. Okay. Anything else?
Can we find the maximum and minimum of a function?
Yes, absolutely. Yes. And we have had a very specific type of problem that you will see over and over. So we can look at that, or you can choose any other problem. So a very simple situation in which, if you remember, we have a farmer who has a rectangular plot bordering on a river, and this is X, and this is X, and this is Y, and he has, let's say, fencing. Give me a number. How many feet of fencing? Any number you want. I'm going to say 1,000. So this is a restriction, right? So x plus y, so 2x plus y has to equal 1,000, because that's all he has. But he wants to maximize this area. And we have to tell him, sir, ma'am, you want to use this particular width and this particular y, and there is no other option for a maximum area. If you deviate from the x and the y that I'm going to give you, you will not have a maximum area. You will have an area, but not the maximum. So in order to find the maximum area, you have to write x times y. From here, you have to solve for y. -2x plus 1,000. And you have to plug it in here and get a function of x. -2x squared plus 1,000x. So this is quadratic. How do I find the max or the min of a quadratic function? This is it. How do I find the max or a min of a quadratic function? Anyone remembers a formula? The formula will become kind of redundant in the next class because we have a more sophisticated, more interesting way of finding max min. Much better. The formula is strictly for quadratic, but what we learn in Calc 1, it will be for any function. But here we don't have that. We only have formulas. How do I find the maximum of a quadratic function? Anyone remembers, please? Max min of a quadratic function.
-b over 2a.
Thank you. B is 1,000. 2 times a is -4, so we have 250 feet. So this is 250 feet. But I have to find y. So -2 times 250 is -500, plus 1,000 is 500. So we will tell the farmer, ma'am, sir, make sure that the width is not less and not more and 250 feet, and your length is 500 to guarantee a maximum area. And he's going to say, what is the maximum area? No problem. 250 times 500. So max.
Is
Or,
that an L over the 2A?
say it again.
Is that an L over the 2A?
So the quadratic function is ax squared plus bx plus c. That's the quadratic function. So this is the a, and this is the b. And the formula is negative b over 2a. Negative b over 2a. So negative in front, b is 1,000. 2 times a is negative 4. This division is 250. Is that okay?
Yeah, I understood the thing. I just couldn't tell what symbol that was.
It's b. It all depends on the coefficients in the quadratic function. So the maximum area is, what was I saying? 250 multiplied by 500. Or you just go back to the area, put in the calculator so you don't make a mistake, and replace x by 250. You have to get the same answer. So 5 times 125 is 125, and I see 3 zeros. And you have to write feet for this, and you have to write square feet for the area. Please remember the measurement units, always. Any questions on this? Any questions? So again, the formula is negative b over 2a. B is the coefficient of x in the formula. That's why you have to present it in descending order so you don't make a mistake in selecting the coefficients. That's why I always have it in descending order. So negative b over 2a, we got 250. Make sure you don't get a negative number, right? So 250 is the width. I determined with 250, negative 500 plus 1,000 is 500. So we tell the farmer the width must be 250 and the length must be 500. Any other combination will not give you the maximum area, sir. Any other combination. This is the only one. 250 by 500. Okay, perfect. Next topic.
Is the process the same for those if you're finding the minimum?
Yes, absolutely. Absolutely. Negative b over 2a. If the
What would
function
be
is
different?
if the function is quadratic. But in this class, you can only have quadratic, unless we use a calculator. We may be given a cubic function, but we have to use a calculator. We don't know how to determine max min for cubic functions yet. Sorry, you were saying something, Blake.
I was just asking what would be different between if like you were asked a minimum, would it just literally just be the same?
It's absolutely the same. It's just that the function has to have a positive leading coefficient.
Oh, okay.
The quadratic with a negative leading coefficient has a maximum. Quadratic with a positive leading coefficient has a minimum.
Oh, okay. Thank you.
Thank you. Next topic, please. Next topic. Next question, please. Have you turned in the take-home part?
Not yet.
Okay. Please finish it up so I can grade them tomorrow, hopefully. Is the binomial theorem clear, or we need to go back?
Can you go back to it?
Yes. You want to choose one? Anything? You can choose any binomial, any power. But don't choose 15 because it's going to take us more than 5 minutes. Do I choose?
You can choose.
Okay, I'm going to choose power 6 and a simple one, 2x minus 3y. Coefficients for power 6. The initial coefficients, not the ending coefficients. 1, 1, 1. 1, 2, 1. You know that this is power 3. You know that this is power 2 because there are 3 coefficients. 1, 3, 3, 1. Power 4. 1, 4, 6, 4, 1. There are 5 coefficients, meaning that's power 4. This is power 3, power 4, 5, and 6. I have to have 7 terms. So 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. These are the coefficients for power 6 because I have to have 7 terms. 1, 2, 3, 4, 5, 6, 7. So 1 in front, 2x to power 6 minus 6 in front. So positive, negative, positive, negative, positive, negative, positive. It's negative 6. 2x decreases its power from 6 to 5, and 3y pops in. 15. 2x decreases its power from 6 to 5 to 4, and 3y has to increase its power from 1 to 2. Notice one thing, power 6, power 6, power 5 plus 1, power 6, power 4, power 4 plus 2, power 6. Initial, this is not done, minus 20, 2x decreases from 6 to 5 to 4 to 3, 3y from nothing to power 1 to power 2 to power 3, 3 plus 3 has to equal 6. I'm here. 1, 2, 3, 4. 1, 2, 3, 4, 5. So I'm here. 15. 2x from 6 to 5 to 4 to 3, now to 2. Then 3y from nothing to 1 to 2 to 3 to 4. 2 plus 4 equals 6. I'm here with minus 6. 2x from 6 to 5 to 4 to 3 to 2 to 1. Now 3y from nothing to 1 to 2 to 3 to 4 to 5. 1 plus 5 is 6. Final one plus 3y to power 6. There is no 2x anymore. So now 2 to the 6th times x. Where is my calculator? So that's I don't need the calculator for that, but I need to prepare for the rest. So I know that this is 64. So this is x to the 6th minus I have 6 times 2 to the 5th, which is 32, and times 3. 576 x to the 5th times y plus I have 15 in front times 2 to the 4th, which is 16, times 3 squared, which is 9. 2160 x to the 4th times y squared minus I have 20 times 2 to the 3rd, which is 8, times 3 to the 3rd, which is 27. 4320 x to the 3rd, y to the 3rd, plus I have 15, 2 to the 2nd power 4, times 3 to the 4th, What is 3 to the 4th? 81. Okay, 4860 x squared y to the 4th minus, I have 6 times 2, which is 12, times 3 to the 5th. Okay, I got 2916 x and y to the 5th. And finally 3 to the 6th, which is positive 729 y to the 6th. And no, I'm not gonna use power 6. It's too long.